Hello student, myself Dr. M. K. Zate. Today we will see the one chapter thermometry. So thermometry is a branch of physics which deals with the study of the measurement of temperature. So first of all we will know what is the uh, temperature. Okay. So temperature is a physical quantity or we measure the degree of hotness of a body. So temperature is measured by the thermometer. The thermometer is an instrument that for measurement and indicating the temperature. So what is the need of measurement of temperature instead of heat? Because we cannot measure heat of any material directly. Because for that purpose we require the specific heat of that material and the quantity of that material. So instead of that, we measure temperature. So for measuring temperature, we need a thermometer. So in this lecture, we will see the types of thermometer. So there are, these are the types of thermometer: liquid thermometer, gas thermometer, bimetallic thermometer, resistance thermometer, and thermocouple thermometer. So we will see one by one of the all thermometers. So first is a liquid thermometer. So liquid thermometer are based on the principle of change in the volume of liquid with change in the temperature. As the volume of liquid get changes, the temperature get changes. Means if the temperature of the liquid get changes, then volume of that liquid get changes. So thermometer is suitable for the narrow range of measurement. Most commonly used liquids in these thermometers are the alcohol or mercury, and the range of this thermometer are minus 39 degrees Celsius to 357 for the mercury, whereas for the alcohol it is used to measure the temperature near about the ice point. So we will see the construction of this thermometer. So it consists of a sealed stem uniform small bore tubing called a capillary tube made up of a glass with a cylindrical glass bulb formed at a 1 end. And the bulb and part of a stems are filled with a liquid such as mercury, alcohol, and remaining part is empty or the evacuated. The temperature scale is formed by etching the graduation on the stem. The safety reservoir is usually provided into which the liquid can expand without bursting the glass if the temperature is raised beyond upper limit of the scale. So this is a typical thermometer, that is a mercury thermometer, liquid thermometer. So you can see here, these are the points. The capillary tube is there, the stem is there on which the scale is there, and mercury threads on which we can see the mercury is shown, and the glass bulb is for the containing the mercury inside. So you can see the on the thermometer 25 degrees Celsius is the temperature that is measured on the scale. So advantages of mercury thermometer. So it is good conductor of heat and whole liquid acquire temperature of a body quickly. So this thermometer can give the very good reading as it absorbs the quick heat. The next is it has a low specific heat and hence it absorbs low heat from object of which temperature being measured. Due to the low specific heat, so it cannot absorb all heat from the object. If the object is very small, so there is a very accurate reading. So it absorbs the very low heat from the substance. It does not make wet inner of the wall glass tube. So in the inner wall glass tube, if the liquid is get attached or it make wet, so some part of the liquid is attached, so we will not get a proper reading. So in case of this mercury thermometer, the mercury does not attach to the inner wall and we get the accurate reading. It can be observed easily in a fine capillary tube. So mercury can be absorbed very easily from the capillary tube as it sparkles. It has uniform coefficient of expansion over the wide range of temperature. Because of the uniform temperature range, so it can be used for the wide range because the expansion is linear at every expansion is constant. So it remains liquid over the wide range of the temperature because of its freezing point is a minus 39 degrees Celsius and its boiling point is a 357 degrees Celsius. So it can measure the temperature in between that. So what is the disadvantage of the mercury thermometer? It has a paging point, high paging point, and it is expensive. Mercury is an expensive substance. It has a low response, and mercury is a toxic. If it breaks, and it is can be harmful to our body. Then next is a liquid filled thermometer, alcohol thermometer. So this is a typical alcohol thermometer is shown in this diagram. So it consists of a liquid, then bulb, then that bulb is connected to the capillary tube, and that capillary tube is connected by a Burden tube. And as this bulb is kept in the contact with any substance of that we are going to measure temperature, the liquid in that bulb will get expand, and because of the expansion, the burden get displaced. Okay, because of the displacement, we will get the deflection, and this deflection is proportional to the change in the temperature. Then working of this liquid thermometer, basically the ethyl alcohol or the toluene have a volumetric expansion 6 times greater than that of a mercury, and liquid is normally put under the pressure and are completely filled bulb and tubing. When bulb is immersed in heated substance, the liquid expand causing a Burden tube to unwind or get it displaced. So here the sensing device at a differential volume indicator. The response is linear to temperature change. The working of liquid thermometer depends on the volume change of liquid with respect to change in the temperature. So this change of the temperature with time with temperature T can be given by equation Vt is equal to V naught 1 plus beta into T, where Vt is a volume of temperature at T degree Celsius, V naught is a volume of liquid at 0 degree Celsius, and beta is a coefficient of expansion or the volumetric expansion, and T is a rise in the temperature. So what are the advantages of this thermometer? It expands uniformly, it has large expansively, then it has a lower freezing point, that is minus 115 degrees Celsius. Then what are the disadvantages of this thermometer? It wet the tube. Because it wet the tube, the some part of the alcohol or the liquid remains in the tubes and we will not get the correct reading. It has a low melting point, that is 78 degrees Celsius, so we cannot measure the much temperature. It has a high specific heat capacity. Because of that, it absorbs more heat from the system and there is a reduction of the actual temperature of the system. So there may be the error in that measurement. The next is a gas thermometer. So the liquid thermometer, where the latter replaced by a gas thermometer as their expansion is larger and the measurement is more accurate. The expansion of a container is small in comparison with the gas. Whatever we are taking the bulb or the container, in comparison to that, the expansion of gas is more and expansion of container is less. So there is a less error in the measurement. The permanent gas can be obtained in a fewer form. Whatever the gas we are putting in the container, that can be get in a purified form. Then expansion uniform equal changes of the temperature at a low and high temperature. Since it has a uniform expansion over the low as well as high temperature, so it is a change in the linear temperature. Okay. Then upper limit of temperature measurement is a much greater than the liquid thermometer. The types of gas thermometer, there are two types of gas thermometer. One is a constant volume gas thermometer and constant pressure gas thermometer. So here is a gas thermometer. It consists of a bulb B connected to glass tubing, and then the end of that glass tube connected to the reservoir of mercury through a rubber tubing. So the M is a fixed mark on the tube, and the difference in the level of the mercury in R and M is noted on a scale by height h. So the bulb B is filled with the 1/7 of the volume of mercury, and this gives the volume of air in the bulb up to the marks and M constant as shown in figure. So working and calibration. So for calibrating this thermometer, we have to take the bulb B first of all in a melting ice. So and the reservoir R is suitable adjusted so that the level of mercury stand at M. So we will get the H0 difference level between R and M, and P and P0 is the atmospheric pressure and pressure of measured at the melting point of the ice. So this is given by equation. The total pressure is P0 is equal to P plus H0. Again, we put this bulb in a boiling water, and the reservoir is adjusted to the level M. At this level, the H100 is a difference level between the R and M, and P100 are the atmospheric pressure and measured pressure at a boiling water. So we will get the equation P100 equal to P plus H100. Again, whatever we want to measure the temperature, then put that bulb in the temperature. Let us say that is a T temperature. So again the equation will be the Pt is equal to P plus Ht, and solving this equation and putting the expansion coefficient, we will get this formula, and from the last two equation, T is equal to Pt minus P0 divided by P100 minus P0 into 100, measuring the pressure, and we can measure the height ratio, the St minus S0 divided by S100 minus S0 into 100. So knowing the pressure or the height, change in the height, we can see, we can measure the temperature. So this is a constant pressure gas thermometer as shown in figure. The bulb C is connected to graduated tube E of the manometer through the fine capillary, which is bent twice at a right angle. The manometer tube B and A are same diameter filled with the mercury and connected to a reservoir R through a stop cock D. The bulb C full of gas is kept in the reservoir, and the temperature of the gas rises. Advantages of this gas thermometer: the coefficient of expansion of gases is very large compared to liquid, so therefore they are sensitive, and the gas expand uniformly and regularly over the wide range of the temperature. Then gases can be obtained in a pure form. They are suitable for measuring ring, low and high temperatures. And what are the disadvantages of this gas thermometer? One, limited maximum temperature, then much lower accuracy, sensitivity and the temperature span compared to other types of thermometer. Then in case a failure of entire system is we have to replace the system if there is some fault occurs in the thermometer. Then it needs a large bulb for the sake of accuracy. Then next type of thermometer is a bimetallic thermometer. So bimetallic thermometer works on the principle the bimetallic strip which converts the temperature into mechanical displacement. The mechanical displacement of bimetallic strip is by virtue of its thermal expansion. So the thermal expansion is tendency of metals in which the volume of changes with the variation of temperature, and this change in the expansion are proportional to the temperature. So this is a typical bimetallic thermometer as shown in figure. So the metal has a property of thermal expansion and the metal expand and contract concerning the temperature. So the temperature coefficient of all metals is not same and the expansion contraction of metal is different at the same temperature. So the construction of bimetallic thermometer. So this is a figure showing a bimetallic thermometer of two stages, that is one is a undeflected and deflected in. Okay. The bimetallic strip is constructed by bonding together the two thin strips of different metals. The green and other is a creamy color. These are the two bimetallic strips. They are connected. Then the metals are joined together at one end with the help of welding, and the bonding is kept in such a way that there is no relative motion between the two metals, and the physical dimension of the metals varies with the variation of the temperature. So at the temperature get changes, the strip get bended in one direction. So depending on the construction, the types of bimetallic thermometers are categorized into two. One is a spiral strip bimetallic. So in bimetallic strip thermometer, the spiral shaped strip is used and it is used for measuring the ambient temperature. The pointer and dials attached to the spring which indicate the variation of temperature. So this is a typical bimetallic thermometer that is in a spiral form. Next is a helical type thermometer. So the helix type bimetallic strip is mostly used for the industrial application. In this thermometer, the helix shaped strip is used for measuring the temperature. The free end of the strip is connected to a pointer and the deflection of strip is shows a variation of the temperature as shown in figure. So what are the application of bimetallic thermometer? The bimetallic thermometer is used in household devices such as oven, air conditioner and industrial apparatus like refineries, hot wires heater, then tempering tanks for measuring a temperature. Advantages of such thermometers: it is simple in construction, robust and less expensive. And the disadvantage of this thermometer is it gives the less accurate result while measuring the low temperature, because at a low temperature metal change in the deflection is very low. The next type of thermometer is a resistance type thermometer. So some metals when kept in a contact with temperature, there is a change in the resistance of that metal, and this property is used for the measuring the temperature. Then example of such metals are the platinum, copper, nickel. If the alpha is the temperature coefficient of the resistance, RT and R naught are the resistance of a given temperature at T and at 0 degree Celsius, then we will get RT is equal to R0 plus R0 alpha T, or RT minus R0 is equal to R0 alpha naught. On that we can find the change in the temperature of the system. Next type of thermometer is the platinum resistance thermometer. It is a again resistance thermometer. So platinum resistance platinum thermometer is shown in this figure. So P is the platinum wire that is kept in a system of glass, and C and C are the compensating wires. The platinum resistance of the platinum and the P are the same at the 0 degree Celsius. So this is a typical figure of the platinum thermometer. So the change in the change in the resistance of this platinum wire is a very small. For that purpose, for measuring the change in the temperature resistance, we use the Wheatstone bridge as shown in the figure. So this Wheatstone bridge can be balanced for measuring the temperature. So this measuring the temperature of the balancing condition is given by R1 divided by R2 is equal to R3 plus Rs and R4 and divided by R5. So Rs is the resistance of the platinum, whereas the R1, R2, R5, R4 and R3 are the constant. So the balancing condition, for balancing condition we have to measure R3 or R4 so that we will get the balance of the bridge. Then advantages of this platinum resistance thermometer. The measurement is very accurate. The accuracy of measuring circuit can be easily checked by substituting the standard resistance of the resistive element. Then resistive element can be used to measure a differential temperature. It has a wide range from minus 200 degrees Celsius to 1200 degrees Celsius. They are best suited for the remote indication, then extremely accurate temperature sensing, and no necessity of a temperature compensation. Disadvantages of this thermometer, it is a very high cost because platinum is a very costly material. Need for bridge circuit and power source, then possibility of self-heating, then large bulb size compared to the other thermometer. So it become a bulky thermometer. Then next type of thermometer is the thermocouple type thermometer. So its work on these three principles: Thomson effect, Peltier effect and Seebeck effect. So we know that when the two metals are kept in the contact with two junctions of the two different metals, when are kept in the contact with the two different temperature, so there is a generation of EMF in that system. So that effect are called the Peltier effect, and vice versa is a Seebeck effect. Then working of this thermometer, we can see that A and B are the two joints together forming a specific junction P and Q having a temperature T1 and T2. The both junctions are being maintained at a dissimilar temperature, therefore forming a Peltier effect, and the EMF is generated in the circuit, and this generated EMF is proportional to the difference in the temperature of the two junctions, and this phenomena is used for the determining the temperature of the system. What are the advantages? It has a accuracy high, then it is robust and can be used in the environment like harsh as well as a high vibration. So thermal reaction is fast, and the operating range of the temperature is wide, and wide operating temperature range. Its cost is low and extremely consistent. So what are the disadvantages of this thermometer? Non-linearity. So the change in the temperature in the thermocouple, it is a non-linear. So we have to apply the mathematical relation for the making it linear. Then least stability. So it has a minimum stability, and the generated EMF is so smaller that we have to use the precise instrument for measuring the change in the voltage. Then it require a reference voltage or the reference source. Then least sensitivity, thermocouple recalibration is hard. So the thermocouple calibration is a very hard. So this is one of the typical type of thermometer, that is a type of thermocouple. So thank you. This is the end of the lecture.